Well, hello friends. Today we are going to continue working on the JavaScript engine, and we're going to do something with strings. So last time we left off, we were doing this program right here, which is variables and adding variables together. So if we go and look at our little test utility, I think this is the program that we were testing now by default. So we're going to write a new program, which we'll call number 4. And this setup is a little bit weird, but bear with me. So today we're going to do something with strings, like I said, and I think we're going to make it real simple. We're just going to create a string called like hello friends, and then we're going to get the length of it. So this, in order to support this, we're going to have to do all kinds of things. Because we need property lookup, and primitive strings in JavaScript are not objects, but when you do a property lookup on a primitive, then it needs to sort of synthesize an object just for the lookup, so we need to do that. And I think this will be interesting. So let's just run this through one of those parsers that we've been borrowing. And Conrad tipped me about this thing called ASCExplorer.net. And this website is really cool because you can choose between different parsers. So we can use like Esprima, which I've been using before, but we can also switch to like Babel. Kind of cool. So we'll try writing a little program here. And I was playing around with these a little bit, and I noticed that they all create basically very similar things, right? Which is what you would expect. Although the Esprima one, somehow I still find it a little bit easier to read. Maybe it's because it's shorter. Regardless, let's see what we get from this. So we have a expression statement, and we've been sort of skipping over those. But inside it, we have a member expression. And actually here, when you hover something, then it highlights in the source what it is that you're hovering. So that's pretty neat. So we have a member expression with a literal on the left-hand side. Can we open that? Yes. So it's the string literal. And then on the right side of the dot, we have an identifier. So actually pretty simple AST. So let's just write that out. So that would be a member expression, and inside of it, on the left-hand side, we had a literal that said, hello friends, right? So actually, we don't have a way to create a string literal because we've never done it. So I think we'll make a helper for that called JSString, just like JSNull and JSUndefined and those guys. And since a string is going to have to allocate, we're going to need the heap here. So we'll just pass him the heap. And then the string that we want to actually construct. So hello friends in this case. And then the right side of the member expression is going to be an identifier. And it will be length. Okay. So I think this will be our AST. Now, there's a lot of stuff missing here. We don't have any strings, and in fact, in JSValue, I sort of started doing string stuff with the value object, but the string type of the enum internally is actually a string impl, which is sort of an ACK C++ object, and what we want here is really like a JavaScript primitive string, right? So a primitive string in JavaScript is just an immutable sequence of characters that is allocated on the GC heap. So we want to have something like that. And I think we'll call it primitive string. That'll be nice. And it doesn't clash with string, which is our like global string type in the whole project. And of course, this will be namespace, so it's actually like JS : primitive string. But anyway, let's see, MNO primitive string.o. Okay, so here, let's see, so we want something called JS string, or should we have, no, that's a bit on the long side. JS string is fine. And we want to take a heap and just a string, I guess. And then we should declare this class. So primitive string is going to be a cell, because it's garbage collected. Everything that's garbage collected inherits from cell. And primitive string will have a constructor that simply takes a string. Let's put this out of line. But basically this will be how you construct it. And we'll need a virtual destructor. And let's get some includes. We'll need the string actually, because we're going to store it. String, mstring. Okay, and I guess we can expose it. Const mstring. And it's still abstract because we need to implement a few more things. So since it's a cell, we have to implement the class name exactly. Primitive string. And we also need to implement, wait, hold on. We have visit children for the garbage collector marking stuff, but a string, a primitive string has no children, so we don't need to override the visit children thing. Okay. This is a pretty decent looking class, I think. So let's sketch out the implementations of some of these things. So this one is really straightforward, just a string, string, m, string, move, string. Simple enough. Likewise with the constructor, very undramatic. And the interesting one is this guy right here. So heap and string, and then we'll need the heap. So this will be heap allocate primitive string move string. Actually, that's barely interesting. It's so simple. So this will allocate a primitive string cell from the heap and construct a primitive string in that cell and pass it the string as an argument to the constructor. Very good. Okay. So let's look at our test program again. So now we need to actually include the primitive string here. So primitive string, and we need to pass the heap. So I guess we'll just do something like this. Then we gotta rearrange this a little bit. And interpreter heap. There we go. That's pretty good. Okay, so now we are cool with this. The literal takes a value, and then a value. It needs to be constructed from a primitive string, actually. So let's add a constructor for that. So primitive string. It's so long, we can just call it string. And type string. Okay, and let's get rid of the string impl, because we're not going to use that as the underlying string type of a value. We're going to use primitive string. And I think we can put that in the forwarding thingy, just so that they become available here. And now, of course, this is not going to work anymore, so you'll need to ask for a primitive string instead, which is what we can give you. Okay. And let's go look at these toString and stuff like that. The toString actually returns an ACK string here. So this is for like serialization and debug output and stuff. So if something is a string, what we want to return is really the value as string string. And we need the declaration of primitive string in order to see that. Okay, there we go. So now if you call toString on a JS value, and it is a string, then we will call primitive string string, which will give you the string. Cool. And for a Boolean, to boolify, I guess we should, it's just an emptiness test, so we'll do like, if it's a string, we'll do as string, string is empty, non-empty. Then we have all these like logical and bitwise operations and stuff, but well, we don't care about those right now. And one thing that's interesting now is that now we actually have something, or we already had something garbage collected contained in a JS value, because it could refer to an object, but we need to also make sure that when the garbage collector visits a value, it needs to not only look for if it's an object, then visit it as an object, but it also needs to check if it's a string, and if so, we need to visit the string. Lib.js primitive string. I can't call visit. Why not? Wait. Is it a const issue? Yeah, okay. Well, we can get around that. Just have a non-const variant. Although these are both cells, if you think about it. Both object and string are GC allocated cells, so we could also have like is cell, and then we would say like is string or is object. And then we could have an as cell. Return m value as cell, which we can provide here in the union. It doesn't cost us anything. Thanks to the magic of unions, we don't even need anything other than the forward declaration. So that's pretty nice. Okay, so there we go. Then we can simplify this a little bit and just say if it's a cell, then visit it as a cell. Cool. Then let's go back here to our test program. I guess we should probably wrap this in a value because it's explicit. So nah, there we go. Now to come up with the member expression. How is this going to look? Class member expression. So I found this really nice page. It's like the Babel spec. this page right here, or maybe it's here. Yeah, so they have a list of all of the different things that the Babel parser produces. So I find the actual JavaScript spec is like way too obtuse for me, at least right now, and I don't want to deal with its extreme jargon. So looking at something like this is a lot nicer. So we can just go straight to member expression, and look how simple they make it, right? We can just see here that a member expression is an expression or a pattern, and it has a type, an object, a property. It's either computed or not, and then it's either optional or not or null. But object and property, I think, are the ones that we care about right now. So computed member expressions is when you do a bracket lookup, and non-computed is a dot b. So we're doing a.b now, the non-computed variant. So we'll just care about that. So we need object and property. And they will be, let's just go with expressions. And this can be final. So the way you construct one of these guys is an openputter to expression, object, nominal openputter to expression, property. Move property. All right, so there we have those. Okay, and then we need execute and dump, like always. And a class name, of course. How could I forget the class name? So member expression. So now our program here looks like it would even compile. Not so fast. So we changed something about the strings, and wait, where are we? AST304. Primitive string. Wait, literal dumping. It literally dumps. This looks overly complicated. We can probably just do like, just always do toString. Here we go. That seems fine. Maybe literal. Okay. Can we commit that by itself, perhaps? JS simplify literal dump. Okay, so that compiles, and now we just need to implement the famous member expression stuff. So let's see. The dumping is really straightforward because it's just dump yourself, the right indentation, and then dump your object, m-object, dump at indent +1, and likewise for the property that we're looking at. Then we just need an implementation of the member expression execute. All right. So what's that going to look like? Wait, what's not? Oh, it needs to return something, right? So what is this? This is this expression dot this expression. So we want to compute whatever this is, and then do a property lookup in it, essentially. So I guess what we return from this thing should be the result of doing a get of length on whatever this expression returns. I think that would make sense. So let's compute that first, what the left thing is. So like object result is m object execute in the interpreter. And then we want to look this up. So, wait, hold on, what am I thinking? We want to do this, but the left side of a dot needs to be an object, right? This is the thing I was talking about earlier, that to do a dot lookup on something, it needs to be an object, and a primitive, like a string literal, is not an object. So we need a way to go from the literal, or the primitive string, to a string object. String object. Come on, MDN, help me out. String literals, blah, 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 blah. Blah, blah, blah. Okay, just get to the point. Right, distinction between string primitives and string objects. Literals are these things, and JavaScript automatically converts primitives to string objects so that it's possible to use string object methods on primitive strings. So we need to construct a string object implicitly here. And I think what we're going to do is something like toObject. And we'll have to pass in the interpreter. I think maybe we can only pass in the heap, but we need a reference through which we can allocate. Convention seems to be to pass the interpreter, so I guess we can do that. But really, we only care about the heap, so maybe we should start a new convention. So toObject, right, and then toObject goes into the value class, which already has toString, which is kind of weird now because it returns an ACK string. So maybe we should change that, but I guess what we want here is something like a interface like this, right? toObject. And this will produce, if the value contains an object already, represents an object already, then it will just return the object. But if it's a primitive of some type, then we'll construct a wrapper object around the primitive. Because JavaScript has like string objects and Boolean objects, number objects, and things like that. And we need to know how to synthesize those. So, I think we'll put this somewhere here, like toString, toBoolean. And this will be value toObject, which gets a heap reference so that we can allocate. Okay, so if is object already, return as object, wrapped in a value. Okay, and then if it's a string, then return, it's not interpreter, heap, allocate, string object, string wrapper, string wrapper. Should we call it string wrapper? Nah, maybe string object is better. Wrapper, I don't quite like that one. And they call it string object here a lot, so I like sticking with names that people already understand. And it seems like we need the JS heap here, so heap, and we have to actually declare string object. And then for anything else, if you want to turn anything else into an object, we'll just assert that you don't get here, because I'm not going to implement that right now. Okay, now we need a string object. So that's where we're going to sneak in the length property, by the way. So when we construct the string object, we're just going to put a length property on it. I think normally what happens is that length is actually on the string prototype, but we're not going to do prototypes today. That'll be another video. Right now we're just going to make a string object, put a length property, and then make sure that this code can actually access the length property. And that'll get us ahead, I think. This will be some good stuff. So let's invent the string object, the JS string object. String object, all right? So name space JS class string object. And again, this is going to be a garbage collected cell. So we'll need cell. And internally, it will just have our primitive string. So this is going to be sort of a wrapper around that. And the way that you construct one of these is you just give it the primitive string pointer. I think that would be it for the constructor. And virtual const char class name return string object. And of course, in this case, we actually do need to do something for the garbage collector, because a string object internally has the primitive string, and we have to tell the garbage collector that if this one is live, then this one is also live. So we gotta mark it, make sure that it gets marked when we get visited. So virtual void visit children, right? So this is a child of the string object. And let's implement that visitor right now. So string object, string object visit children, cell visitor, and we can just call, actually, we shouldn't inherit from cell, we should inherit from object, because we are an object. We can have properties. I just realized that I'm about to put a length property on this guy, so we need him to have object facilities like properties. So primitive string, string, primitive string, or we can just call it string. Okay, so when we visit, we'll visit the object children, and we will also visit visitor.visit our primitive string. Here we go. I can't call that because I don't see the fact that primitive string is a cell. There we go. All right. And the length property, I think we can just add it in the constructor right here. So we'll just do something like this. The length is the mstring string length. Okay. JS value is incomplete. I think we need to explicitly say that this is a value, and there's no value constructor that takes a size t, so we will cast it to an I32 and hope that it fits. Famous last words. So see you here in 12 months when we do the exploit explanation video about this. Anyway, let's not get ahead of ourselves. So now we can construct a string object when we need it, when the member expression calls toObject, passing the interpreter heap. So, okay, now we have a value containing a string object, and we're just going to assert that we have a value here, I think, because I don't want to deal with the different possibilities, because we don't have exceptions yet, so we can't throw. We'll get there too in some other video, but one thing at a time. So we'll say that it's an object. Okay. And then we want to do a lookup. So in our case, the right-hand side is an identifier. So if we execute the identifier, then it will do a variable lookup. So we don't want to execute the identifier, but instead we want to actually use it as a property name for the lookup immediately. So we'll say if the property is an identifier, property name is mProperty. We'll cast it to an identifier dot string. All right, and then we don't deal with the other scenario right now, because I guess you could have another expression on the right-hand side. I'm not quite sure. That would be in the case of a computed lookup, for example. So if we were doing 1 plus 2, 3, apparently, then we would need to actually evaluate this expression. So that would be this branch right here, but we are not supporting that right now. We're only doing the a.b case. So now we have a property name, and now we want to do a lookup. So return object result dot as object get property name. Okay, is this it? Alright, so this now constructs a member expression. We got a literal with the string on the left, and we got an identifier with length on the right. Member expression execute will call execute on the object node, which will be our literal. So it will execute that, constructing a JS, a primitive string. And then toObject will construct a wrapping string object that internally refers to the primitive string. And then we will assert that it gives us an object back, because this thing can also fail, right? And this guy right here is going to need to include a string object. Right. And actually, we are not passing him anything, so we need to give him our string. There we go. So yeah, so toObject on the value realizes the value is a primitive string, constructs a wrapper object, and that object is then used as the base for this get. Okay, let's try it. I feel good about it. Okay, maybe I needed to string. I needed the destructor for string object. I think I declared that, but didn't define it. So okay. Literal hello friends. Length 13. I feel like that might be accurate. How long is that? hello, friends. Is that 13? I guess so. Hello is 5. Friends is 7. You got one space in between, so that's 13. It's pretty good. So it works. Amazing. And you can see here that the garbage collector that we run on exit, it notices that while the global object is still alive, we do have a dead string object and a dead primitive string, so they get garbage collected. That's really cool. So it seems like everything is working. Great. Let's commit some stuff. So is there anything that we can do separately here? I wonder. I guess maybe we can add the primitive string type. Primitive string and makefile. If we only do these, that's a pretty good separate thing. So let's make sure that we don't forget our famous license headers. So JS primitive string, string object. Oh, I'm lying in the numbers because I wrote this today, not 2 years ago. Everybody saw it. So let's make sure we get these right. All right, there we go. Add those guys again and see what we have now. So we're just adding the primitive string class, which has an ACK string internally, and it's garbage collected. So I think that's really good. And yeah, we'll go with this pattern where you pass the heap by reference. For any function that needs to be able to allocate a new object, it's going to need a reference to the heap because you have to allocate through the heap. Okay, that's good. So let's commit that. Lib.js, add a new primitive string plus to hold GC allocate strings. Right. And then, poof, string object. We can do him next. So string object, and we'll need the makefile, and maybe we don't need more than that in this commit. Let's see, it's just a string object and you can construct it as you like. Yeah, let's commit this separately. So add string object, an object wrapper around primitive strings. This object will soon be allocated on demand when doing things like doing something like a property lookup on a primitive string, or let's see, allocated on implicitly created to wrap a primitive string when one is used in a context that requires an object. Okay. Then what did we do here? It was a cell change, right? And this guy right here, oh, JS this one is kind of silly. To forward.h. Yeah, we can probably squash that one. Then the rest is kind of interdependent stuff. So let's see. Or maybe I'm not right about that. Yeah, well, we can actually commit this in one go. That's fine. libjs support hello friends dot length. And actually, let's include the test program. So support hello friends dot length. The above snippet is a member expression that necessitates the implicit construction of a string object wrapper around a primitive string. We then do a property lookup, a get on the string object where we find the length property. This is pretty neat. Okay, so that turned out pretty good. And I'm pretty happy with that. Oh, wait. I've seen this bug sometimes. I don't know what the heck that is. Maybe the literal should actually have quotes if it's a string, because that's a little bit weird. Or I don't know. I don't know. Maybe we can do something like that. And let's rebase a little bit here. So we'll take this little literal change. Ah, dang it. I needed a longer rebase. This one goes in that one, and then this one goes in that one. All right. And you go away, and cool. So let's just verify that we're still good. But I think this is pretty good progress. Yeah. So this will be it for today's video. If you made it this far, then I thank you for watching and for hanging out while we continue to implement more of libjs. I hope you saw something interesting today, and I certainly am learning so much about JavaScript that I never learned or never knew, despite having worked on a browser engine for so many years. It's so different to do the thing from the bottom up rather than going and optimizing something in a already really mature engine. So this is incredibly educational for me and really fun, and I hope some of that translates through the video. So thank you for watching, and I'll see you next time.